All right, guys, happy Friday. Welcome to Integrated 2, Section 5-8, Properties of Circles. Before I get any further, I want to remind you that you do have a homework assignment, and it is on the board behind you. You're on page 228 to 229, 2 through 28 evens. Don't forget to write that down and have it in your notes before you leave, in your assignment notebook before you leave, okay? Our goal today is to understand relationships between parts of circles and identify and use their properties, okay? Before we go any further, what I want to let you know is that you obviously have a handout in front of you. You're expected to fill that out while you're going through and watching this video. The sub will pause the video at any time you need to, go back anytime you need to in order to catch up, because I'm going to go faster than what it would normally take to go through a normal class, okay? So you will probably need to pause and look at this later. I will also put this information on my website, okay? So do your best to keep up, but do realize that I do expect you guys to pause. I will be going faster than normal, okay? So definitions. Make sure you fill these in as we go through. First thing we're going to talk about is, well, what the heck is a circle, right? A circle is a set of all points that are given distance from one point, okay? Set of points that are given distance from one point. Obviously, you know what a circle looks like, but this is the formal definition. Here is the point, okay? And here is the distance that all of the points on a circle are from that center point, okay? All right, so as we go through, I would encourage you to draw pictures. I have stuff on there for you to draw on. This would be one of those times. Obviously, the center of the circle is that fixed point that we talked about, okay? It's the point in the middle. Obviously, you guys can locate that. A term that you've heard of before, a radius. It is the given distance from the center of the circle. So I'm going to draw a radius on here. If I start at the center and go out to the circle, that is my radius. Now I can draw plenty of radii. Yes, I said radii. That's plural for radius. I can draw many radii. In fact, I can draw infinitely many radii on this picture. Those are just two. Okay. Now, a term that you probably haven't heard of before is the term chord. A chord is a segment with both endpoints that are on the circle. So neither one of these radii are as a chord, but if I put an endpoint on a circle, both my endpoints on the circle, and now I make a line segment between those, that would be a chord. And if I label this like AB, then I have, in fact, a line segment AB, and if you relate it to the circle, now we call it chord AB. Now, watch this. If I were to actually take this chord and move it to the center and maybe make it a little bit longer, what would it look like? Well, wouldn't it look just like a diameter? And that's exactly what a diameter is. A diameter is just a chord that passes through the center of the circle. So if I'm drawing my pictures here, then a chord that passes through the center of the circle would look like this. So I can call this XY, and XY would just be a line segment, and when I relate it to the circle, it is a diameter, okay? Here are the definitions. If you need to pause and copy them down, please do. I'm going to go further. Okay, so let me change this real quick. All of these should be capitalized. All your points are usually capitalized. Had a brain fart, I guess, when I was making this. D, E. Okay, so name two chords. Well, chords are line segments that have their endpoints on the circle, so I can say chord AC. I could also say chord BD. Then it says name three radii. Well, I have a radii here, radii FE. I have a radii here, radii FD, and I have a radii here, a radius here, FB. Okay, so those are my three radii. And then it says name a diameter. A diameter, again, is a chord that just goes through the center. So I could use chord AB as my diameter. Okay. This is going to be kind of an example of what your homework's going to ask you to do. Okay, I'm sorry, I said chord AB. I meant chord BD. BD. So your homework is going to ask you label these parts of this of the circle, and this is exactly what you're going to have to do. Keep in mind when you say things like radii or chord, you will probably have multiple answers. Okay. All right, moving on. We have more parts of a circle here. Again, I encourage you to pause when you need to. Okay, so a central angle. What's a central angle? Let me get a different color here. A central angle is an angle that has its vertex as the center of the circle. So it has its vertex on the center, and the sides of the angle go through or to the circle. Now, think about this. An angle that has its vertex as the center. The vertex, remember, is the corner of your angle. So that means it's on the center. So here is the center. Here is my vertex. That is a central angle. Okay? That's a central angle. Central angles usually cut out something called an arc. An arc is a section or part of the circumference. Okay? Part of the circumference. So if you look at what my central angle has cut out here, it's cut out that part of the circle. And I can label it. I can put AB here, and I can say that I have arc AB. Now, think about this. Whenever we talk about like a line segment, let's say I draw a chord through here, and I have chord CD, all right? That's a line segment CD with a line over the top. An arc is labeled with an arc over the top. Makes sense, doesn't it? If it's an arc, draw an arc for the label. Okay? Make sure that you do that for your homework and get into the habit of it. I will be looking for that on a quiz or test. Okay, moving on. Semicircle. Okay? A semicircle is half a circle. Okay? It is an arc that has the diameter as its endpoints. Okay? So what does that mean? Let's look. Here's a diameter. Goes through the center of the circle. And it says that now I've made a half circle. Well, yeah, obviously I've cut it in half. All right, but the semicircle's definition is that it's the arc that is cut out by that diameter. So if I use this diameter, let's say this is AB, right? Let's say this is AB. That means that I've cut out a semicircle here, and I've also cut out a semicircle here. So I've actually made two. So let's look at how we label it. It says that it's labeled with 3 points. Okay. Now, why do you think that is? If I talk about, well, semicircle AB, look at it. Well, half of you are probably looking at the one on the right. The other half of you are probably looking at the one on the left. Okay. We need a third point to determine where we're talking specifically when we talk about a semicircle. So what is used is a third point, and it's in between the endpoints of diameter. So let's just call this like X. Okay. Now I can properly label this as semicircle AXB with my arc over the top. Okay. AXB would be a semicircle. Okay. Then we have something called a minor arc. Okay. In relationship to the semicircle, all it is that it's smaller than a semicircle. It's smaller than half the circle. And because it's smaller than half the circle, we only need 2 points to label it. So if we go back to the drawing here, I could say that arc AB is a minor arc. It's smaller than half the circle. If I want to draw another one, let's call this TW. I can call this minor arc TW. And I would label it in the same way with 2 points. TW minor arc. Okay. So then what do you think a major arc is? If a minor arc is smaller than half the circle, a major arc is larger than half the circle. Pretty easy to remember, okay? And again, it's labeled with 3 points, okay? It's labeled with 3 points because if you look at the drawing that I made, if I talk about major arc TW, well, I could be talking about this arc that I drew before or this arc on the other side of the circle. So again, we need 3 points to label that. So I'm going to go ahead and put another point here, and let's call this maybe, let's call it, I don't know, D, okay? And now I have this semicircle that I'm drawing, and I can label that, not semicircle, major arc. I can call that major arc, what did I label it? TVW. Major arc TVW. Okay, so those are the different parts of the circle. A central angle, it has its vertex as the center of the circle. An arc is cut out by an angle. A central angle will cut it out. Also, another angle that we're going to talk about later will cut out an arc. Semicircle is half a circle. Minor arc is an arc smaller than half circle. Major arc is bigger than half the circle. Okay, if you need to stop filling notes, do so. I'm rolling. Okay, measurements of arcs now. Okay, let's say that we want to give a measurement for an arc. Measurement of a minor arc is equal to the related central angle. So let's look at this circle that I'm going to draw on here. Here is a central angle. Let's say I have it as 40 degrees, okay? And again, I can label my arc like this. Here's A, here's B. And I would say that the measurement of arc AB, again, I have to have my arc symbol over the top, is equal to 40 degrees. So we measure our arcs in degrees, just like we measure them with angles, and they are related to their central angle. Okay? Now, the measurement of a major arc and minor arc are related. Major, minor are related. When I cut out this minor arc here, when I cut out this minor arc, I also created a major arc, right? Well, can I find the measurement of that? Let's use this as an example over here. Let's say that that's my central angle, and the measurement of that central angle is 50 degrees. And I'll label this T, R, and we'll put this as X over here, okay? And I've now created a major arc on the other side of the circle. And I want to know how many degrees it is. Well, what's the degree distance all the way around a circle? 360 degrees, right? So if I want to find the degree measurement all the way around for the major arc, all I do is take 360 minus the related minor arc. That's the definition. The measure of a major arc is found by subtracting its related minor arc. So if I take 360 and I subtract 50, I get 310 degrees. So this measurement here is 310. Okay? Major and minor arc measurements. So let's look at some examples. Okay? I want to find the measure of minor arc EB. Okay? Minor arc EB is here. Again, if it's a minor arc, I'm labeling it with 2 letters, like I've done, and here we go. Now, here's the thing. I don't know what this angle is, because usually what I would do is take, well, 50 plus whatever this angle is and add them up, right? But I don't know what it is. But can't I also just subtract those angle measurements, and whatever's left will give me the minor arc EB that I'm looking for? Absolutely, that will. So let's do that. So if I take 360 minus 65 minus 120, what do I get? I get 175 degrees. So the measurement of minor arc EB is 175 degrees. Okay? Now think about that. If this whole thing here is 175 degrees, what does that make this small arc AB, minor arc AB? Well, I would take 175 minus 50, and this one here is 125 degrees. Now we know everything about this circle. So let's go through and find out some more answers here. I want to find the measurement of major arc EBD. So let's look where that is. EBD And let me do some erasing so we can make this a little more clear. EBD is this circle here. EBD is that major arc there, okay, from here to here. Well, how do I find the measurement of EBD? Can I just subtract 65 from 360? Absolutely. Because I know that the rest of it is 65 degrees, right? So just subtract that. So I take 360 minus 65, and that gives me 295 degrees. So I would say the measurement of major arc EBD, arc symbol, is equal to 295 degrees. And if I want to find the measure of major arc ABD, let's take a look at where it is. ABD, do some erasing. ABD, all I have to do is add up this angle plus that angle, and before we said that that angle there was 125 degrees. So all I got to do is add up those two angles. 125 plus 120 will give me 145 degrees. Sorry, 245 degrees. So these are example problems of what your homework will look like. All right, we're in the home stretch now. If you need to pause and take notes on this, please do. Otherwise, we're going to talk about the last part of our circles and do 2 more examples here. All right, last thing that we're going to talk about. An inscribed angle, okay? An inscribed angle is an angle that has its vertex on the circle. It is not on the center. The vertex is on the circle, and the sides are chords, okay? The sides are chords. So that means I have to have 2 chords that actually meet together on the circle. So here's a point on the circle. Here's a chord. Here's a chord. This is called an inscribed angle, okay? So there is a relationship between this angle measurement here and the angle that's created with the central angle that goes out to those same 2 points, okay? Here's the relationship, and here's what you need to write down. The measure of an inscribed angle is half of the measure of the arc it intercepts. Half the measure of the arc that it intercepts, okay? So let's say that this arc that it's intercepted, this arc right here, let's say that we call that AB. And I say the measurement of arc AB is equal to, let's say it's 70 degrees, okay? Let's say that this measurement here is 70 degrees. Well, if I want to find the measurement of the inscribed angle right here, well, all I got to do is take half of 70. So what's half of 70? 35 degrees. Okay? And if you're given this angle, all you got to do is double it to find the measurement of the central angle that is related to it. All right. So let's go look at some examples. I want to find the measurement of angle ADC. Okay? ADC is here. It is an inscribed angle. And what did we say we would have to do in order to go from the related central angle to the measurement of the inscribed angle? We would have to cut it in half. So what's half of 74? 74 divided by 2 is equal to 37 degrees. So this is 37 degrees. Okay? Last question we're going to talk about. Okay? It says if major arc RYE is 260 degrees. Let me bring this up a little bit. Major arc RYE is 260 degrees. So this arc here is 260 degrees from here to here, right? Then I want to find the measurement of angle RYE, which is this angle here. Okay, this is a multi-step problem. This is putting everything together. If the distance from RYE is 260 degrees, then what is this remaining distance here? What is that? I guess maybe I shouldn't cross it out. Like, I want to know what this is. Well, again, the distance all the way around the circle is 360. So if this piece here is 260, that means that minor arc RE, this here, minor arc RE is equal to 100 degrees. And if this is 100 degrees, then I can say that, and that would be the angle, the measurement of the central angle RTE. This here would be 100 degrees. So then I can say that the measurement of angle RYE is half of that. And half of 100 is 50 degrees. Okay? So that's today's lesson. Don't forget about your homework assignment. I know it's a lot of information, but the video is online. You have your note sheet, and you can view this stuff at any time. Homework tonight, you're on page 228 to 229. You're doing 2 through 28 even. I hope you guys have a good weekend, and I hope that you got something out of this video. Have a great day. Peace.